Now that we've finished up the unit circle, is what we're going to do is we're going to learn about 4 more functions other than sine and cosine, and then we're going to practice using that unit circle. Okay, and let's just go ahead and start off here with this first one, tangent. So its abbreviation is TAN. Okay, and the way that we're going to define this is if we were to take tangent of some angle, it is equivalent to sine of that same angle over cosine of that angle. Okay. Or if we wanted to even write it a different way, right? If we're thinking about our unit circle, sine of theta is y and cosine theta is x. Okay. Next one on the list, cosecant. And it is abbreviated CSC. And so cosecant of theta is equal to 1 over sine theta. And again, sine theta can just be thought of, if we're thinking about the unit circle, just 1 over that y coordinate. Okay. And then secant. So secant of theta is defined to be 1 over cosine of theta. And we could rewrite that as secant of theta is equal to 1 over x. Okay. And one thing that might help you remember the definitions for secant and cosecant is that it goes the other way you'd think. You'd think that cosecant would be associated with cosine and secant would be associated with sine, but it's actually the other way around. Okay. And then we're on to our last one, cotangent. And so cotangent of theta, you could actually think of as just 1 over tangent of theta, or cosine of theta over sine theta, right? Because they're each other's reciprocals. Okay, and the last way we could represent this is x over y. Okay. So now that we know about these 4 functions and the other 2, we're going to see if we can evaluate them at certain angles using our unit circle. Okay. And let's go ahead and start off here with pi over 6. Okay. So before I go back to my unit circle, we need to remember that sine of an angle, that's going to be the y coordinate on our unit circle. Okay. So let's go back. Here's our unit circle. And you might already see pi over 6. It's right there. And if we were to look at the y coordinate, that is 1/2. So sine of pi over 6 is equal to 1/2. Okay. So we'll jump back here and we'll write that in. 1/2. Okay. Next, we're on a cosine. So that's going to be the x value on the unit circle. So we just need to find the angle 5 pi over 3 on there. And I'm going to get rid of these arrows, and it looks like I already have an arrow pointed to 5 pi over 3 over here. And again, we were looking for cosine of 5 pi over 3. So we should be using the x coordinate. So we get 1/2 again. Let's try another one. Tangent of 5 pi over 6. So remember, this is going to be the y coordinate over the x coordinate. Okay. So let's go find 5 pi over 6 on our unit circle. Okay. Here it is. And again, we want to do y over x. So 1/2 over minus the square root of 3 over 2. Right? And since we're doing a fraction divided by a fraction, we'll take that bottom fraction and we will flip and multiply by it. So it's minus 2 over the square root of 3. Okay. And right, 2 divided by 2 is just 1, so those 2's cancel. So we just have minus 1 over the square root of 3. But then we could still rationalize the denominator. And this gives us minus the square root of 3 over 3. All right, on to cosecant. Okay, so we know that cosecant is supposed to be 1 over the y-coordinate, or 1 over sine. All right, 1 over sine of pi over 3. So let's go to that unit circle, find pi over 3. It is right here. Okay, and sine is the y value, so we're going to do 1 over that y value. So 1 over the square root of 3 over 2. Okay, and if we do 1 divided by a fraction, we're just going to get its reciprocal. And then if I rationalize the denominator, we'll get 2 root 3 over 3. All right, let's try secant of 0. So this one should be easy. We just need to find 0 degrees or 0 radians on the unit circle. And right, secant is 1 over cosine, so we want 1 over the x value. So we're looking right here, 1 over 1. Okay. I'm going to add in an extra step here, though. That one that we did say, though. And this is 1 over cosine of 0, and cosine of 0 again was 1, so we get just 1. And then cotangent of pi. So we know that this is supposed to be the x coordinate over the y coordinate. Okay. So let's go take a peek at that. If we find pi over here and we do the x over the y, well, the x is minus 1 while the y is 0. So minus 1 over 0, that's undefined. Okay. So we actually don't get anything here. We just get undefined. Okay. All right, let's go ahead and start what we have here on this page. So we're now going to look at even and odd functions. Okay, and so some of you might remember even and odd functions in a slightly different context than we're going to talk about them right now. So one of those contexts might be, well, if you do have an even function, which I'm going to just make a little set of axes here real quick. There we go. An even function and this is just graphically here, but this one would be even. And the property that it has is it's symmetric about the y-axis. Okay, right? It looks the same on both sides of the y-axis. Okay, and then another one of these would be odd. So let's make a sketch of an odd function. There we go. And an example of an odd one would actually be a cubic. And here we call this symmetric about the origin. Okay. And if we were to look at what these mean algebraically, well, if it were odd, you might see, some angle, let's see, some angle theta here. And if I were to go over here to say minus theta, the idea is that these two numbers, let me put them in red, this spot and this spot right here, they're the same number other than their sign. Okay, so f of minus theta is what I'm trying to say is equal to minus f of theta. Okay, so they're just off really by a negative sign. Okay. And then even, we could say something similar if I were to, again, maybe put an angle here and another angle equally far in this direction minus theta. The idea is that this should be at the same height, okay, the same y value. So as what I'll write here is that f of minus theta is equal to just f of theta. Okay, and again, that was for even functions, and the first one was for odd. Okay, and so it actually ends up that sine, cosine, tangent, cotangent, secant, cosecant are all either odd or even. They're one or the other. Okay. And so what we're going to do is we're going to figure out which ones are odd or even and talk about why.